And so that is the last subject that we can do very quickly, which is the reionization era, the cosmic renaissance that follows up the Dark Ages. And here is a schematic cartoon, what that might look like. Very far away is microwave background, and nothing happens. Dark Ages, then you start having these first bubbles of ionized gas. Eventually they overlap completely, and the universe is transparent to UV light. Ta-da. This happens roughly when the universe is between a few hundred million years old and 1 billion years old. Now, interesting thing about this is that theoretical models tell us that first stars that form will be more massive than stars that are forming now. Stars that are made out of pure hydrogen and helium tend to come in larger masses than those that are made out of already chemically enriched material like sun has, right? And because they're very massive, they'll be very luminous and very hot. And these are the theoretical upper main sequences for regular population 1 stars, like disk stars here now, and then for the population 3 stars, those first primordial stars, and you can see that they can go to millions or tens of millions of solar luminosities at very high temperatures, and so that's plenty of ultraviolet radiation to ionize all of the gas in the universe at the time. Actually, the idea is that you make 1 star per protogalaxy that ionizes everything, then it has to explode before anything else can form. And they do explode quickly, and that releases some metals in the interstellar medium of the protogalaxy, and then the population 2 normal stars start to form. So this has now been modeled to great detail, but observations are still pretty scarce. One interesting way is to look for gamma ray bursts, because very briefly they're really luminous. And this is the one that's likely at the redshift 8.2. The data were not super duper convincing on this, in my opinion, but it has a good chance of actually being a stellar explosion, maybe of one of those primordial POP3 stars at the redshift 8.2, when the universe was only a few hundred million years old. The way we have studied this is by looking for complete absorption of ultraviolet light, blue or the Lyman alpha line in quasars. That's called the Gunn-Peterson effect. And that was seen maybe like year 2000, 2001. And we know now that reionization era ends at around redshift of 6, when the universe is about 1 billion years old. It begins earlier, probably around redshift 15 or 20, when the very first stars form, but it takes some time to actually build up both sources of light and to actually ionize the gas. So the next frontier is before there are any stars. How can you do this? You can look for neutral hydrogen that's not yet converted into stars in 21 centimeter line, and you can compute how much of that you should see. And so people are hoping to see maps of highly, highly redshifted neutral hydrogen during the Dark Ages, before any galaxies even lit up. And so that is something that will hopefully come along over the next 10 years or so.